All right, good morning. Again, we're looking at the first test becoming available on Friday, wrong month, Friday, February the 5th. And for what we have in the case of review, okay, so we have for number 32, okay, we have just going back to utilizing the FOIL method. Okay, so we're looking at a couple of binomial expressions in the variables w and y. And so here we have the quantity of 5w cubed plus 6y squared times the quantity of 2w cubed minus y to the second. And if we multiply out, again, you can choose either or any FOIL approach. Okay, and so if I go with the traditional route, okay, so we have 5w cubed and 2w cubed will form the first product. Okay, so we have 10w to the sixth, and for the outside terms, now we have with 5w to the third times negative y squared. So here we're going to have minus 5 times w to the third times y squared. And for the inside product, okay, so you have positive 6 times positive 2 is going to form 12. And with the variables attached, and if I put these in alphabetical order, so you have w cubed, y squared. And for the last product, we have 6y to the second times the negative of y to the second. So we're going to have a negative 6 times y to the fourth. And combining the like terms in the middle. Then we have the outside, the inside products. Okay, so we have in this layout, so you have 10w to the sixth. And again, we have minus 5w cubed y squared plus 12w cubed y squared. And so this will come out to positive 7 times w to the third times y squared minus 6 times y to the fourth. Okay. And that would be the outcome for what we have in number 32. And for what we have in the case of working with multiplying polynomials, and we have in the case of number 34, and we have for this one, okay, so we have the quantity, okay, we have 9 times t minus 4, and we have times that of 9t plus 4. And again, so we have binomial terms that are the same, except you have subtraction in the first binomial, addition in the other, but everything else being the same. And so we're going to arrive at a difference of squares. So if I were to FOIL out, you have 9 times t times 9 times t. So you have 81 t squared. For the outside and inside products, there will be additive inverses of each other. So you have plus 36t minus 36t. And the last product, okay, we have a minus 16. Again, the outside and inside products cancel. So we have for the end result, we have the difference of squares with 81 t squared minus 16. And transitioning from multiplying polynomials to factoring. And we have in the case of number 46, and here we have a trinomial, okay, where we have somewhat raised coefficients, raised in terms of the absolute value with the first and the last terms. Okay, so you have 12t squared minus t minus 6. And now you could do stuff like, using trial and error, and you need the right combination of factors. Okay, that will result as 12t squared minus t minus 6. So what we can do, instead of using trial and error, we can once again utilize factoring by grouping. Okay, so again we have looking at the first and the last coefficients. The first coefficient is positive 12. The last one we have at minus 6. And if I multiply together, we have the product at negative 72. And with negative 72, I'm looking at numbers that will multiply into negative 72, but that will add up to negative 1, which is the middle coefficient of this trinomial. So we have, in the case of factors of minus 72, factors of negative 72, whose sum will be negative 1. And if you notice, in terms of how we got to the number negative 72, I had multiplied 12 and negative 6. And this is not going to be the combination. You have 12 and negative 6. 12 times negative 6 is negative 72, but the sum would have to be a positive 6. But I'm looking at a combination that will add up to negative 1. And that combination, we have negative 9 and positive 8. Negative 9 times 8 is negative 72. And negative 9 plus 8 is a negative 1. So this will be the combination we're looking for. And so for what we have in the case of this trinomial, so again, we're going to use the negative 9 and the 8. Use that combination to form first order variable terms in t. And it technically doesn't matter which order you place, but I like, if I have a negative and a positive factor, I want to put the positive coefficient inside the second term that follows, because it's going to safeguard that the middle operation, once I make the trinomial into a 4-term expression, is going to be addition. Okay, so I have 12t squared. We have minus 9 times t. And we have plus 8 times t minus 6. And then crossing over to the stage of factoring by grouping. So I have pairing up the first two terms. So I have 12t squared minus 9 times t. And we have the middle operation, okay, which is addition. And I have the quantity of 8t minus 6. And as long as the middle operation is addition, I'm not going to have to perform any changing of the signs. But if I had negative 9t to follow 8t, I would have to perform sign changes. Okay, but with the addition in the middle, okay, I have everything secure as it already is. Okay, now for the first binomial, okay, so you have 12t squared minus 9 times t. And the greatest common factor, okay, now both these are variable terms, and the highest number that will go into both 12 and negative 9 is going to be 3. So the greatest common factor, okay, we're going to have it 3t, and taking into 12t squared minus 9 times t. So you have 4t minus 3. And looking at what we have upon bringing down the addition. Okay, so we have in this one, there we go. And the greatest common factor of 8t minus 6. Okay, that is going to be at 2. And 2 will go into the quantity of 8t minus 6, 4t minus 3 times. And so for what we have common to both groups, we have 4t minus 3. Then we have times the quantity of 3t plus 2. So we're going to have for the end result for 12t squared minus t minus 6. Again, we have the quantity of 4t minus 3. And we have times that of 3t plus 2. And you can once again check 4t times 3t is 12t squared. Outside part is 8t. Inside part is negative 9t. So you have the difference, you have negative t. And negative 3 times 2 is negative 6. Alright. Now, in looking at what we have in the case of factoring by grouping, and we have in number 47, okay, so here we have 8x cubed minus 40x squared y plus 50xy squared. Okay, now we're going to have a trinomial to factor, but let me mention something. I went ahead and drew out the binomial factors, and reason I went into this automatic mode was that the greatest common factor with these three terms in the original presentation was 1. So I was able to go ahead and tackle what binomial factors there are. Now for 47, it's not quite so automatic. Here, if you notice, you have even numbered coefficients, and there is a common factor that is greater than 1. And in fact, not only do we have an even coefficient, we also have the letter x that is shared. And so if I were to draw out the greatest common factor, okay, so you have x in common, and we have the highest number that go into all of 8, negative 40, and 50. That is going to be at 2. So the greatest common factor will be at 2x. And for what we have in the layout, so you have 2x will go into 8x cubed, 4x squared times 2x into negative 40, x squared y. Okay, so you have 2 will go into negative 40, negative 20 times, x will go into x squared, x times, and then we have y left over. And 2x into 50x y squared. And that's going to leave us with 25 y squared. Now from this factor trinomial, we are going to have binomial expressions, and we'll have the letters x and y involved. Okay, so in the case of the trinomial, so if I step to the side here, and again you have the right degrees, especially in the middle term. So you have like for x squared, okay, you're going to have the middle term is going to have half the degree of x squared, and likewise for 25y squared, the middle term should consist like half the degree of y squared, which we do have in y. So you had the right proportions, not only among the coefficients, but also what we have in the variables. So you have for 4x squared minus 20xy plus 25y squared. Okay, so if I multiply the first and the last coefficients again, okay, so I have 4 times 25. Okay, so this will come out to 100. And now, okay, again, we had the middle coefficient, negative 20. And we want to find the right combination that will multiply such that the product is 100, and also where the sum will be at negative 20. Okay, so we have 4 and 25. 4 times 25 is 100. 4 plus 25 is going to make 29. Okay, and that's not the sum we're looking for. And in fact, what we will end up having as the right combination will be negative 10 and negative 10. Negative 10 times negative 10 is 100. Negative 10 plus negative 10 is going to be negative 20. Okay. So that'll be the combination we're looking for. Okay, so I'm going to split up the negative 20xy again into xy terms with negative 10 as the coefficient. So bringing on down what we have here. So you have 4x squared, you have minus 10xy, minus 10xy, plus 25y squared. Okay. And then crossing over to the stage of grouping. So we have the quantity of 4x squared minus 10xy. So the middle operation we have to be subtraction. So you have minus 10xy plus 25y squared. This is going to be the opposite sign of 10xy and negative 25y squared. Again, when the middle operation is subtraction, be careful with the parentheses around the last two terms. Okay, so you have negative 10xy plus 25y squared. And looking at drawing out the greatest common factors. Okay, so we have for 4x squared minus 10xy, so we have even coefficients, and we have the letter x in common. So the greatest common factor is going to be 2x, and we have taking into 4x squared minus 10xy. So we have 2x minus 5y. And bringing down the subtraction. Now for 10xy minus 25y squared. Now the greatest common factor, okay, had the letter y involved, and the highest number into both 10 and negative 25 is going to be 5. So the greatest common factor here is going to be 5y. And into 10xy minus 25y squared, we will also have 2x minus 5y. So looking at what we have, we got 2x minus 5y. And combining the outside terms and operation. Okay, so we have the quantity of 2x minus 5y. And notice we have a repeating binomial factor. And for that which repeats once, we're going to take that factor and raise to the power in accordance with the number of appearances. So we have the quantity of 2x minus 5y squared. So for what we have within the framework, okay, so I had factored out 2x from the start, and for this trinomial we have 2x minus 5y quantity squared. So just relaying this back to what we have in the original problem. Okay, so we'll end up with 2x times the quantity. Okay, this will be of 2x minus 5y raised to the second. And this will be the final answer for what we have in the case of 47. All right. Now, for what we have in the case of the next item, I don't think on the test there will be the factoring of subs and differences of cubes. But just in case that there is, okay, I just wanted to mention or bring up what we have in the case of 54. Alright, so right now we have a trinomial where we have m to the 6th plus 9m cubed plus 8 is going to be the trinomial to factor. And if we factor, notice we have for m to the 6th plus 9m cubed plus 8. Now we have this particular equation is going to be quadratic in form. And in fact, we have, you notice we have an m, we have a 6 to 3 ratio between the higher and lower degrees, and 6 to 3 reduces to 2 to 1. And so this trinomial is going to be quadratic in m to the third. And if the coefficients are just right, we can take this expression and factor the leading term into factors that the expression is quadratic in. So we have for m to the sixth, okay, this will factor out to m to the third and itself. And then we have for factors of 8, whose sum will be 9, okay, we'll have a positive 8 as well as a positive 1. Okay. Now, for m cubed plus 8 and m cubed plus 1, okay, those are cases of what we have for not differences, but for sums of cubes. And for the sum of cubes, again, we have for a to the third plus b to the third. Again, you're going to have a binomial factor and a trinomial factor. Binomial factor would be just like taking the sum of the cubic roots of a to the third and b to the third, so that is just going to be a plus b. And for what we have in the case of the trinomial factor, we have a squared minus ab plus b squared. And for what we have in the case of m cubed plus 8, okay, so m to the third, okay, we have the cube of m. 8 is going to be the cube of 2. So you can think of a as being represented by m and b as represented by 2. So for that which is representative of a plus b, we're going to have m plus 2. And then we have for the quantity of a squared minus ab plus b squared. So you have your a squared, this will translate out to m squared. And we have for minus ab, we have minus m times 2, so this will be a minus 2m. And for plus b squared, 2 squared is going to be at 4. So you have m plus 2 times the quantity of m squared minus 2m plus 4. And for what we have in the case of m cubed plus 1, okay, so that's like m to the third plus 1 to the third. So a is represented again by m, b is now represented by 1. So we're going to have the quantity of m plus 1, and representing the trinomial a squared minus ab plus b squared. In this case, we're going to have m squared minus m times 1, which is going to be negative m. And we have plus b squared, and 1 squared ends up at 1. So for what we're going to have in the results, so we have for, once again, for m to the 6th plus 9m cubed plus 8. And just somewhat shifting over. And it doesn't matter what order you place the factors, but with m cubed plus 8, I'll just go ahead and write those factors out first. So you have m plus 2 times m squared minus 2m plus 4. And as for what we have for m cubed plus 1, so you have m plus 1. You have times the quantity of m squared minus m plus 1. Okay. So for the complete factorization, okay, we will have 4 factors with integer coefficients, 2 that are binomials and 2 that are going to be trinomial expressions. All right. Now, in the crossover, now for what we have working with rational expressions, now we looked at operations, but when we first, I believe when we first looked into fractions, okay, we looked at factoring and finding out what restricted values there are in the variable or variables of concern. And for what we have in the case of 61, okay, you're looking at simplifying the ratio, whereupon we have m squared minus 16 is all over the trinomial, whereupon we have m squared minus m minus 12. And if we look at reducing the ratio, so for m squared minus 16, okay, so this will go to m plus 4 and m minus 4. For the trinomial, okay, if I factor, okay, we're looking at m squared going to m times m, and then factors of negative 12 whose sum will be negative 1. So we have more weight given to the subtraction, in this case minus 4, than to the addition, which we have plus 3. And notice, okay, we have a common factor between the numerator and denominator with m minus 4. So for the complete reduction, okay, we have m plus 4 all over m plus 3. So that is the simplified version of this ratio. But now for the restricted values, okay, you're looking at, again, preventing the denominator from coming out to 0. All right, so just taking what we have now, so you have m squared minus m minus 12, because it's in the denominator. Again, you cannot divide by 0. And again, when we had factored this trinomial, okay, we had m minus 4 and m plus 3. And just looking at what we have here, so the trinomial cannot be factored such that we have the product to be equal to 0, and the factors cannot be 0 either.
I didn't get that. Could you try again?
Sorry.
It's okay.
The wonders of technology. All right, so you have m minus 4 and m plus 3. Okay, so you have the m minus 4 cannot be equal to 0. All right, so I had the m cannot be 4, and we had the m cannot be equal to negative 3. Okay, so again, let me just mention, okay, so the trinomial cannot be equal to 0 because it's in the denominator position. And again, we have two restricted values with 4 and negative 3. So m still cannot be 4 and m cannot be negative 3. And let me mention, just because m minus 4 cancels, that does not undo the original setup. That disallows m from becoming 4. Okay, so we have for the restricted values, all right, so you have 4 and negative 3. Okay, now for what we have in the case of rational expressions, if we look at combining, okay, at least along the lines of adding together, okay, and we have rational expressions that do not have the same denominator. Okay, so we have, in looking at combining, 7 over 20x and 2 over 15x to the fourth. Okay, so to be able to add together, okay, we at least need a common denominator between 20x and 15x to the fourth. Okay, and just kind of mention, okay, so if you have like the number 20, and I express in terms of just prime factors, so 20 Okay, you have 2 times 10, or 4 times 5. 2 is a prime number, since the only positive numbers that will factor into it will be 1 and the number 2 itself. Now for 10, 10 can factor out to 2 times 5. And all of 2 and 5 will be prime numbers. And for the number 15, okay, 15, this will factor out to 3 times 5. And 3 and 5 again are going to be prime numbers. And again, we have with the variable factor, okay, that is only x. And for the prime factors, okay, so you have 2, 3, and 5. And for what we have in the case of the least common denominator, okay, so with the prime factors 2, 3, and 5, okay, so you're looking at the most highly representative factorization appearances of each. So with 2, it comes out twice from 20 but not at all from 15. For 3, it appears once from 15. And then 5, it appears once for both 20 and 15. So the highest representation you have appearing twice for 2. For 3, it appears once. And then 5, it also appears once. And then for the variable factor x, we have the higher or highest degree representation will be x to the fourth. So the smallest term that both 20x and 15x to the fourth will go completely into, that is going to be 60x to the fourth. And so looking at what we have in the ratios and expressing in terms of the least common denominator, okay, so just kind of moving what we have here. So we have our 7 over 20x. If I write in terms of the least common denominator, okay, so 20x will go into 60x to the fourth. So that'll be 20 goes into 63. X will go into x to the fourth, x cubed times. So 20x into 60x to the fourth will be 3x cubed. So I'm going to multiply this ratio by 1 in the form of 3x cubed over itself. As for what we have in the case of 2 over 15x to the fourth. Okay, now we got the same degree in the variable as what we have in the least common denominator. So we have left over, you have just 15 will go into 64 times. So this ratio will be multiplied by 1 in the form of 4/4. And once we multiply, okay, now both denominators will be converted to 60x to the fourth. And we can go ahead and combine the numerators, whereupon we have 7 times 3x cubed will be 21x cubed. And we have 2 times 4, which is going to be 8. And so we have for the end result, okay, we have 21x cubed plus 8 all over 60x to the fourth. Now, just sort of somewhat expanding the model as we go from 2 to 3 ratios. And we have a number 67. Okay, so we have so we got 4 over x squared plus 3 all over x plus 3. And we have minus 2 over x. And for what we have in this setup, now we're going to have for the least common denominator. Okay, now everything is in x. Okay, but you have a monomial or single term expressions of x with x and x squared, and then you have the only two-term expression x, which we have in the binomial x plus 3. And that, which will be the least common denominator, that all of x squared, x plus 3, and x will be, we have with the single terms. Okay, we have from x and x squared. Okay, we have x squared, and then we have the binomial x plus 3. And just taking what we have and rewriting. Okay, so we have with 4 over x squared. Okay, so for what we have in the mix, okay, so we have for 4 over x squared. We already have the x squared factor, but we are missing the x plus 3. So the first ratio will be multiplied by 1 in the form of x plus 3 over itself. Then we have next in line, okay, so we have, so we got 3 over x plus 3. I'm sorry, I'm going to go ahead and put the first ratio in parentheses. Now for 3 over x plus 3. Okay, now we have the x plus 3 factor, but we are missing the x squared. So I'm going to multiply by 1 in the form of x squared over itself. You have minus 2 over x, and this one perhaps the trickiest, because we have, if you take x into the least common denominator, okay, we still have a factor in x that remains, and also you still have the x plus 3 to work with. So just multiplying by 1 in the form of x times the quantity of x plus 3 over itself. And for what we have in the development, okay, now so all the denominators will be of the form x squared times the quantity of x plus 3. So you have x squared, x plus 3, x squared, x plus 3, x times x is x squared, and then we have times the quantity of x plus 3. Now for what we have with the numerators, okay, we have 4 times quantity of x plus 3. We have plus 3 times x squared. And you got minus, and you got 2 times x times the quantity of x plus 3. Okay, so looking at what we have among the distributions that we have in the numerator. So 4 over the quantity of x plus 3. So we have 4x plus 12. And we have plus 3x squared. And then we have negative 2x over x. We have minus 2x squared. And negative 2x over 3. So this will be a negative 6x. And for what we're going to have in the end result, I can put the numerator terms in most any order, but I'm going to put the terms in descending degree order. So we have in the x squared terms, I have 3x squared minus 2x squared, so this will leave x squared. And for the first order x terms, I have 4x and negative 6x, so this will be a negative 2x. And we have a plus 12. And we have all over x squared times the quantity of x plus 3. And that'll be the final result in this case. All right, and for what we have in the case of rational expressions, okay, this time, okay, with numbers 65 and 67. Okay, I combined rational expressions, and I used the least common denominator. Okay, where I had all the fractions presented were expressed in terms of the LCD. Now, in the crossover to, say, the case in 76, now I have terms that are rational expressions, and I'm going to be looking at utilizing the least common denominator. But I'm going to use the least common denominator not to convert the fractions in terms of that LCD, but I'm going to use the least common denominator to cancel out or remove fractions, because we're going to have an equation in this problem. Now we have in the variable m, now we have m plus 3, okay, that m plus 2 over 3, and we have minus m minus 4 over 4, and we have is equal to m plus 1 over 6, minus 1. Okay, and we're going to use the least common denominator. Okay, now we'll just kind of give you kind of draw this one on out. Okay, so 3 is already a prime number. For number 4, okay, 4 is going to be 2 times 2, and 6 is going to be 2 times 3. So again, you have your prime factors with only 2 and 3. And for what we will have in the case of the least common denominator, okay, no variable factors in the mix. So with 2, okay, the biggest representation among the 3 factorizations we have coming from 4. As for the number 3, it appears at most 1 time. So the least common denominator, okay, we're going to have it 12. And I'm going to use the 12, not convert the thirds, the fourths, and the sixths in terms of twelfths, but I'm going to use 12 to cancel out the denominators. And it's because we have an equation upon which I'm looking at solving for m. So just distributing 12 among the terms. Okay, so I have 12 times. Okay, m plus 2 over 3. We got minus, okay, and we have 12 times the quantity of m minus 4 over 4. And we have equal to 12 times the quantity of m plus 1 over 6. And also you're going to have 12 to be distributed over minus 1. Okay, so we have in the setup. Okay, so if you look at it through the lens of cross multiplying, so you have 3 will go into 12 4 times. And we have 4 will go into 12 3 times. And 6 will go into 12 2 times. And we have in the rewrite, so we have 4 times the quantity of m plus 2. Then we got minus, and we have 3 times the quantity of m minus 4. And again, we have 6 will go into 12 2 times. And this will be 2 times the quantity of m plus 1. We have minus 12 times 1, so this will be minus 12. And so carrying out what we have upon distributing, okay, so we have 4m plus 8 from the first distribution. And we have with the next negative 3 over the quantity of m minus 4. So this will be negative 3m plus 12. To the right, I have for 2 times the quantity of m plus 1. This will be 2m plus 2. Then we have followed by the subtraction of 12. Okay, so for 4m minus 3m, this becomes m plus 8 plus 12 becomes 20. And we have equal to 2m, and 2 minus 12 becomes negative 10. Okay, so we have pairs of like terms on opposite sides. Okay, and we're looking at solving for m. Now, normally I would like to keep the variable I'm solving for on the left-hand side of the equation, but at the same token, I don't care to work with negative terms any more than is necessary. And if you notice, okay, we have the higher m term is on the right, where 2m is greater than m. So if I take m away from both sides, now you could take 2m, but you would have like a negative m on the left. But taking away the smaller, we have that 20 is going to be equal to m minus 10. Okay, and we have just in the follow through. Okay, so if I isolate m by adding 10 to both sides, and it's going to follow that 30 is equal to m Okay, so we have for m, the solution value we have at 30. Now, in the case of what we have for equations, and this time we have a quadratic, and in this one, we're looking at solving for the variable y. Okay, so you have 3y squared minus 4y equals 8 minus 6y. So I have a quadratic equation, okay, in terms of the variable y, but I do not have this one given in standard form. That is, the equation is not set equal to 0, but I can fix this equation and make it standard. So we have in this layout, okay, so for 3y squared minus 4y, I can move the 6y from the right over by adding. And also I can take the constant 8 and move by subtracting. So the whole right hand side, okay, is going to become negligible. And for what we have on the left, we have 3y squared, and we have negative 4y plus 6y. In this case, we have a positive 2y minus 8 is equal to 0. Now, you could do stuff like factoring by grouping. But since we have the coefficients to be low, and since 3 is a prime number, if this trinomial is factorable, 3y squared will automatically factor out to 3y and y. And I'm looking at the combination of factors of negative 8 that will ensure that the sum of the outside and inside products will be at 2y. So you could use factoring by grouping, but also it could take a bit of guesstimating, so to speak, and you can have something like among your possible trial and error approaches, you could have something like let's say 3y minus 1 times the quantity of y plus 8 and 3y plus 2, y minus 4. And I'll just kind of mention, okay, now for what we have throughout, okay, we have 3y times y. So all these will begin with 3y squared. Now the last product, negative 1 times 8, 2 times negative 4, 4 times negative 2, negative 4 times 2. Now the last product will be negative 8, but I'm looking at where the combination will be a positive 2y. If you notice, you got 24y minus y. So that is not going to be it. We got negative 12y plus 2y. So you got a negative 10y. That's not it. And I got outside negative 6y, inside positive 4y. So we have getting closer, but we got the wrong sign value. But we got 3y squared. Now the outside part is positive 6y, inside is negative 4y. So you got plus 2y. Last part is 8. So this is the combination we're looking for. So we have referencing what we have now. So the factorization of this trinomial, we have 3y minus 4, and the other we have with y plus 2. Again, factoring by grouping is an option, but it might be a little bit quicker if you go with the trial and error approach, considering that we have low enough coefficients and considering that 3 is a prime number. Okay, so we have the zero product property. Okay, so if I isolate 3y, in the case of 3y minus 4 is equal to 0, so we're going to have that 3y is equal to 4, and we have a division by 3. Okay, we have y to come out to 4/3. As for y plus 2 is equal to 0, so I have taking 2 away from both sides. So I have it y is equal to negative 2, and so there are two solutions we have for y, okay, which we will have in the case of positive 4/3 as well as negative 2. Yes, you could use the quadratic formula for that as well. It would be a little bit longer a process, but you know, if it could factor, but you could also use the quadratic formula, like setting a to 3, b to 2, and c to negative 8. That is also a possibility. Yeah, so you can use the quadratic formula. All right, and now in the case of okay, just sort of shifting gears, okay, and we have going from rational expressions to rational equations, and then we have quadratic equations, and also we have in the mix, okay, we have radical equations, and we'll get to number 85, okay, but I just want to mention in the case of 86, 85 has two radical terms, 86 has just one. And in this one case, so we have for 86, okay, we have the square root of 51 minus 14x followed by the addition of 4 is equal to x minus 2. Okay, so I have a single radical term, and if I isolate this, I can take 4 away from both sides. Okay, so left hand side we have it 51, the square root of 51 minus 14x, and we have is equal to x minus 6. And again, so I want to take care of the square root. So we can square both sides of the equation. So for what we have left hand side, okay, so this will become 51 minus 14x. And as for the square of x minus 6, again we have x minus 6 times itself. So you have x squared, again you have minus 6x plus 36. So the result here is going to be, once again, a square trinomial, whereupon we have x squared minus 12x plus 36. So we have 51 minus 14x, okay, is equal to x squared minus 12x plus 36. And just taking what we have now with the quadratic equation, okay, and if I put this in standard form, okay, first of all we have the second degree term exclusively on the right hand side of the equation. So I'm going to move the 51 as well as the 14x So we're going to have here, so we got 0 is equal to x squared, negative 12x plus 4x becomes positive 2x. And we have 36 minus 51. Okay, so this will become negative 15. And if I just change the order, like going from b is equal to a is equal to b format, okay, so if I factor this trinomial, okay, so we have, so it looks like we'll have an x plus 5 and an x minus 3. And if I set each of the factors to 0, now we're going to have a couple of apparent solutions with negative 5 and 3. Now it might be that both will be solutions, or it might have one is not going to work out and the other is going to work out. And it may also be that we're not going to have these values to work out, and where we will be stuck with no solution. And so if I test out x equal to negative 5, okay, so just kind of looking at what we have here. Okay, so with negative 5, negative 14 times negative 5 is a positive 70, and 51 plus 70 is going to be 121. So you got the square root of 121 plus 4. And x minus 2, we have negative 5 minus 2. Okay, now right hand side of the equation is going to be negative 7. And if I could reduce the square root of 121 to negative 11, I would have negative 11 plus 4 equal to negative 7. So negative 5 would have worked out. However, with the principal square root rule, the square root of an expression cannot reduce to a negative constant. So the square root of 121 is going to be 11 only. So we're stuck with 11 plus 4. 11 plus 4 is 15. So what this amounts to is that if we set x to negative 5, we're trying to say that 15 is equal to negative 7 and the follow through. Okay, so we're going to have negative 5 is going to strike out. And if I test, okay, x equal to 3. So I got 14 times 3 is 42. 51 minus 42, okay, that is going to be 9. So I had the square root of 9 plus 4, and I have equal to x minus 2, which I will have at 3 minus 2, and had the same kind of predicament. If I had square root of 9 to reduce to -3, -3 plus 4 is 1, which would be the same as 3 minus 2. But with the square root of 9 at 3, and 3 only, we had the left-hand side to be 3 plus 4, which will go to 7, and 3 minus 2 is equal to 1, so I have another false statement. And since 3 was the only recourse in terms of getting to a value after -5 did not test out, it turns out that along with -5, 3 does not work out either. And so we have, because of this, this equation is going to have no solution. And if we could have made the square roots of expressions into negative constants, now both -5 and 3 would have worked out, but because of the principal square root rule, we don't have a solution for either of these values. Okay, now just kind of backtracking, and in 85, okay, so this is one of those problems that will have a couple of terms in the square root, and in this one, so we have for 85, okay, so I have the square root of k plus 7 minus the square root of 3 minus k is equal to 2. And again, I can isolate the radical upon adding, let's say, one of these to both sides. And I'm just going to isolate the square root of k plus 7 So if I isolate the square root of k plus 7, okay, so that's going to be set equal to 2 plus the square root of 3 minus k. Okay, now I can free up the k plus 7 upon squaring both sides. Okay, so on the left, okay, have k plus 7 to be freed up. As for what we have in the case of the square root of 2 plus the square root of 3 minus k, it'll be this expression times itself. And so taking the FOIL, so you got 2 times 2 is 4, and the outside and inside products will be the same. The 2 times the square root of 3 minus k. And we have with the last term, okay, so you're just going to have the square root of 3 minus k times itself. So you have the square root of 3 minus k to the second, which will become 3 minus k. And we have n following through. So you got 4, and we have the middle two terms. We have 4 times the square root of 3 minus k. We have plus 3 minus k, and if we combine the constants, so you have 7 plus 4 times the square root of 3 minus k minus k And just transferring this over. So I can isolate the radical term. And we have at this juncture. Okay, so if I combine, okay, so we got 7. If I take 7 away from both sides, then we have the constants will cancel out. As for negative k, it can move the k over. So for what we will have at this juncture, okay, so you have 2k okay, so I have 2k is equal to 4 times, okay, the square root of 3 minus k. This is optional. You can go ahead and square both sides, but I'm just going to divide the equation by 2. Not by 4, but by 2. And that's, still lowered the coefficients, but still avoid having a fraction. But again, you could square both sides already. But I'm just going to rewrite this where we have k is equal to 2 times the square root of 3 minus k. And we have upon squaring both sides, okay, so we have k squared is equal to, now 2 squared is 4, square root of 3 minus k squared, okay, so you have 3 minus k. Now, squaring the factors on the right, where the process includes undoing the radical. Now, we've squared the factors, but we have not undone the multiplication yet. So if I follow through, okay, so you have 4 times the quantity of 3 minus k, so this would be 12 minus k. And for what we have in this equation, now we have a quadratic. And if I put what I have here into standard form, so adding k and subtracting 12, so we have k squared plus k minus 12 is equal to 0. And we have upon factoring, okay, so we're going to have in the mix, and let me double check here. Divided by 2 times the square root of minus k. Oh, minus 4k, my bad. I knew something didn't feel right. Yes, I have 12 minus 4k. Okay, so if I add 4k to both sides, so you have k squared plus 4k minus 12 is equal to 0. And we have with factoring, okay, so you have k plus 6 and k minus 2 will be the factors. And we have upon setting each of these to 0. Okay, so we have apparent solutions for k. So if k plus 6 is 0, you have k might be negative 6. And if k minus 2 is equal to 0, k might be equal to 2. And just taking what we have now. And let's see if I can get. Yeah, so we have a negative 6 and 2. So if I check k is equal to negative 6. Okay, so plug again negative 6 for k. So we have negative 6 plus 7 is 1. We got minus 3 minus negative 6. Yeah, 3 plus 6, which is 9. We got equal to 2. Now we got square root of 1 is 1, square root of 9 is 3. And left hand side again, we have the operation of subtraction to begin with. So we have 1 minus 3 is negative 2. And this statement is false. So we have that negative 6 will not check out. And for what we have in the case of the value of 2, two plus 7 is 9. So you have the square root of 9. 3 minus 2 is 1. So we're looking at the subtraction of the square root of 1. And now we have the square root of 9 is 3. Minus square root of 1 is 1. 3 minus 1 is equal to 2. And 2 is equal to 2. And that is going to be true. Okay, so negative 6 struck out in terms of qualifying as a solution. However, okay, 2 survives. And so this equation will have one solution. And that is going to be with the value of 2. All right. And we will continue looking into, once again, equations of other types, and just kind of tie in, okay, with the remnants, okay, including the absolute value expressions. And tell you what, just for items next time. Again, for reminders, okay, we have the Alex homework section R8 assignment that is due tonight at 11:59 p.m. And also from the last set of exercises in the book. Okay, also look into numbers 130 and 132, where you're going to have the inclusion of absolute value terms. And again, just repeating the Test 1 announcement. Okay, this will be available through Alex and will be listed as Test 1 on Friday at noon. And again, there will be a 90-minute time limit and must be completed in one sitting. Okay, so don't work this as you might with Alex to say I can save my work and get back to it later on. It must be completed in one sitting. Okay, and the deadline for submitting the exam, okay, will be Monday, February the 8th at 11:59 p.m.